In our skin model, we'll see several different layers, and we're going to call these strata, or stratum to be singular, stratum. If we look at the very bottom, let's just look at the main process. At the bottom is the base cell. So right along here, this is dark, kind of block-like cells, and that's going to be our stratum base cell. And this is where our epidermis originates from. And so as these cells, they're very alive and large and block-like, and they're going to move up into what's called the stratum spinosum. And this is a large, thick layer. I know it doesn't show really well here, but here perhaps you can see it's kind of pinkish. And then as those cells are pushed upwards, they get squashed. And you can see this dark purple line here, just below the white line, and that's called the stratum granulosum. There we have it. And finally, as they're being squashed and being surrounded by keratin, because look at the purpose here, right? We want these live cells to eventually be pushed to the surface and then shed. And I'll tell you why. In our thick skin, we have this extra layer that's called the lucidum, or lucidum. And it's just a white line. It's very thin. And here the cells are being starved of nutrients, and they're starting to die. And they finally end up dying in the stratum corneum. If you look at that word, you're going to see it frequently in anatomy, because corneum, we think of a surface, base cell we think of as the bottom. So here we have thick skin, like in the soles of your feet or your palms. And here the corneum is now essentially dead. And that's what we want it to be dead, because let's say a fungus lands on the skin and starts to grow. We want that fungus to be shed. And so we're constantly losing skin cells everywhere we go. About 40 pounds in a family home. You don't have to remember that, but if you ever emptied a vacuum cleaner bag and see a lot of gray dust, much of that is just skin cells. So below the epidermis, below the stratum base cell, we have, this is dermis. This is the living part of the skin. And in the dermis, we have different glands. One is called let's just write this down. And I'm not sure about my spelling here. I think sebaceous. Yeah. A sebaceous gland is going to be this large, kind of bumpy looking gland that produces sebum. And sebum, here's a cutaway. It's a waxy oil that's going to be excreted to the surface, and it helps to preserve our skin. And most of the time it works, but if we have a hair follicle going through, let's say, the thick part, or parts of our skin where there's an occlusion, then we end up with acne. And part of that is, you see the neck here? If that is narrow, then we start to have a backup of sebum. So often a lot of products that thin the corneum, they will then shorten this channel and reduce the likelihood of acne. So it's usually effective, like Retin-A and those sort of products. Another gland we have is called the sweat, or eccrine. It's an eccrine sweat gland. And here you have it, this white structure here. There's a lot of myths about sweating. You know, we don't really sweat out toxins, but we do cool our bodies through this water, and there's a lot of mineral salts in there as well. And you know, there's a lot of benefits to sweating and saunas for the immune system and so forth. But you just can't sweat out a hangover, like some people believe. The other type of gland is called an apocrine, and this is the it's also a type of eccrine gland, and you'll see it here. This is the one that produces a smelly kind of oil, but you know, it's not smelly at first. It's excreted to the surface, so we think of armpits, groin, and the viscous or oily kind of substance just lays there, and it can be a sex attractant for maybe a day or so. But then bacteria in the skin start to eat this. They love this fluid, and that's where we get our body odor. So what becomes a sex attractant then becomes a sex repellent. It's kind of interesting. Okay, the hair. Hair has several regions, but I'm just going to talk about the three. The outer is called the cuticle. And here you can't see it really well. It's kind of pinkish. and it's alive, but then at the surface it becomes dead, and it's kind of crackly looking. That's a cuticle. Next layer is the cortex, and that's kind of the bulk of the hair. So in this case, it looks kind of brownish. And finally, the medulla, which is, we'll see that word a lot in anatomy. That's the center, and in the case of the center, that's where the hair color is determined. If there's bubbles in there or air, then we get light or gray hair. And if there's a lot of brown melanin, then we get brown hair. So the medulla determines that feature. We'll see some other structures like the erector pili, which is kind of cool. It's a muscle. We don't think of muscles in our dermis, but in this case, the erector pili is a muscle that is attached to, if you look at it, it's attached to the shaft of the hair. And when we're cold, it's going to shorten and elevate that hair into an erect position. And when it does, that kind of folds the skin, and we get what are called goosebumps. And so the hair is now upright, and then we have this warm layer of air that's trapped here. So the benefit of the erector pili is to trap warm air. And so that's why, when we're trying to keep warm, we don't want something really heavy like a leather jacket. It's going to press these hairs down and prevent us from doing our job of warming. So something with bulk, like a sweater or down jacket, is often more effective. Let me see if I can get some lines in here. That would be helpful. Just so we kind of have some baselines here, so we know where the base cell here. Let's see. Yeah, it's at the very bottom layer, and the corneum. That was not very neatly done, but the corneum is the thick. Now don't do your labeling like this. This is sloppy. The lucidum, I think you can see there. The spinosum is the large area just above the base cell, and then above the spinosum, of course, granulosum. Sorry about these lines, but you get my point here. This is all adipose, and the subcutaneous layer that we often measure determines fat. Some of these other nervous system structures I'll talk about in another lecture. Thanks for listening.